In this example, I would like to show you how to compute this integral from 0 to 1 arcsine of x dx. It's not easy to deal with sine inverse or arcsine function inside an integral, so the best thing to do here is to do a change of variable. And to get rid of the arcsine, a good change of variable would be this, x equal to sine of y. Of course, we know that x is going from lower limit 0 to upper limit 1. Therefore, if that is the case, y effectively should go from lower limit 0 to upper limit pi over 2, because sine of pi over 2 becomes 1. So let's make that change of variable. Our integral become 0 to pi over 2, and then arcsine of substituting x with the new variable, sine of y, and d of sine of y. Okay, now the good news is this is super easy. This is effectively just y, so we can write equal to integral from 0 to pi over 2 y d sine y. Okay, now we're going to use integration by part in the sense that we know that integral u dv is equal to uv, of course, upper lower limit, minus integral v du. So we're going to use that. In this case, y is just u, and v is our sine of y. So using that integration by part, we're going to write just simply y sine of y 0 to pi over 2, the lower and upper limit of integration, and then minus integral from 0 to pi over 2. Now it becomes v du, so it will be sine of y, and it would be dy. Okay, so things are straightforward now. This one translates to just pi over 2 sine pi over 2, and then of course 0 substituting y give you 0. So that's the first one. For the second one, we have integral, which is a straightforward sine y dy. That's going to give you a negative cosine. So this will give you negative cosine, and there is a negative behind it, so it becomes positive cosine y, and from 0 to pi over 2. Okay, obviously cosine of pi over 2. So for this one, we have cosine of pi over 2 and minus cosine of 0. Cosine of pi over 2 is 0, and minus cosine of 0 is minus 1. So what we're going to get at the end of the day, and of course sine of pi over 2 is 1, is just pi over 2, and then a negative 1 coming from this negative cosine 0. And this is our final answer, which is the answer for integration to this integral that is shown here. I hope that this is helpful in terms of understanding how to deal with sine inverse inside an integral, and how to use a couple of techniques, including change of variable and also the integration by part to solve the problem. Thank you.